In April 2024, after months of nerve-wracking silence, a faint signal flickered to life from a distance of over 15 billion miles. Voyager 1, humanity's farthest-reaching spacecraft, had spoken again. This wasn't just a routine ping from the void. It was a message that cracked open a Pandora's box of cosmic mysteries, forcing scientists to question everything they thought they knew about the space beyond our solar system. What Voyager 1 revealed wasn't merely a status update. It was a revelation, a glimpse into an interstellar realm that defies our expectations and challenges the very foundations of our understanding of the galaxy. This is the story of Voyager 1's extraordinary journey, its groundbreaking discoveries, and the profound implications for humanity's place in the cosmos. Buckle up. This is real science, raw and unfiltered, unfolding in real time, and it's more gripping than any sci-fi tale. Imagine a spacecraft launched in 1977, venturing where no human-made object has gone before, beyond the protective bubble of our sun, into the uncharted waters of interstellar space. Voyager 1 achieved this monumental feat in 2012, crossing the heliopause, the boundary where the sun's influence wanes and the vastness of the galaxy takes over. This wasn't just a symbolic milestone, it marked Voyager 1 as humanity's first emissary to the stars, a lone explorer in a realm untouched by anything we've ever built. But what it's finding out there isn't just surprising, it's rewriting the rulebook of what we thought interstellar space could be. The heliopause, often imagined as a clean line separating our solar system from the galaxy, is anything but. Voyager 1's data reveals a chaotic, dynamic transition zone, a cosmic frontier teeming with unexpected forces and phenomena. The spacecraft's instruments, though designed for a simpler mission nearly 5 decades ago, are now detecting patterns and structures that no scientist predicted. From magnetic fields that twist in ways that defy our models to plasma waves that hum with the rhythm of the galaxy, Voyager 1 is painting a picture of an interstellar medium that's far more complex and vibrant than we ever imagined. This isn't just a story of exploration, it's a saga of discovery that's transforming our understanding of the universe itself. When Voyager 1 crossed into interstellar space, scientists expected to find a sparse, featureless void, a cosmic desert stretching endlessly between the stars. What they got instead was a revelation. The interstellar medium is alive with structure, activity, and mystery. Voyager's instruments have detected phenomena that challenge our preconceptions and hint at a galaxy far more dynamic than we ever dreamed. One of the most startling discoveries came from Voyager's magnetometer, which revealed an interstellar magnetic field sharply tilted compared to the sun's own magnetic field. Scientists knew the fields wouldn't align perfectly, but this steep misalignment, far more pronounced than anticipated, suggests something profound. Voyager may be skirting the edge of a magnetic turbulence zone. These aren't mere ripples in the cosmic fabric, they're massive galaxy-spanning structures where magnetic fields twist, reconnect, and tangle. These phenomena could be the scaffolding of the Milky Way itself, shaping how energy and matter flow on the grandest scales. Then there's the plasma. Voyager's plasma wave instrument has picked up multiple density spikes, like shock waves rippling through the interstellar medium. These aren't random fluctuations, they're evidence of structured pressure waves, possibly the echoes of ancient supernovae that exploded thousands or even millions of years ago. These shock fronts suggest that the space between stars isn't silent, it's humming with a low frequency oscillation, a cosmic symphony that permeates the galaxy. Picture Voyager not as a craft drifting through emptiness, but as a ship sailing through an invisible fog, layered with regions of varying density and temperature. This is the weather of interstellar space, and Voyager is our first weatherman. What's most astonishing is the structured nature of the interstellar medium. Instead of a uniform sea of particles, Voyager is encountering distinct regions with their own unique properties. Think of them as cosmic climate zones. Some areas are denser, others hotter, and some are threaded with intricate magnetic patterns. These findings are forcing scientists to rethink the galaxy as a dynamic, organized system, not a chaotic void. Voyager 1 isn't just sampling the space between stars, it's mapping the invisible architecture of our galactic neighborhood. The deeper Voyager 1 ventures into interstellar space, the stranger and more intense the environment becomes. One of the most striking discoveries came just after it crossed the heliopause, a sudden, dramatic spike in high-energy cosmic rays. These particles, accelerated to near-light speeds by distant supernovae and black holes, bombard Voyager at rates far higher than anything observed inside our solar system. The transition wasn't gradual, it was abrupt, as if Voyager had crossed an invisible threshold into a a harsher, more radiation-filled realm. This discovery carries profound implications. It reveals that our sun's heliosphere acts as a cosmic shield, protecting Earth and the rest of the solar system from the relentless barrage of galactic radiation. We live in a sheltered oasis, a bubble of relative calm in a stormy galaxy. But the cosmic rays Voyager detects aren't uniform. They show subtle variations that hint at something even more intriguing. The interstellar medium may contain natural corridors, cosmic highways, where these high-energy particles preferentially flow. These patterns suggest a larger galactic structure, possibly a pressure gradient or a low-density void sculpted by ancient stellar explosions. Some astrophysicists now speculate that Voyager could be approaching a boundary between interstellar clouds or even an ancient scar left by a supernova millions of years ago. These findings aren't just local curiosities, they're clues to the cataclysmic events that shaped our galactic neighborhood. Voyager's data is helping scientists piece together a story of cosmic violence and creation, a narrative written in the language of particles and magnetic fields. In late 2023, the unthinkable happened. Voyager 1 fell silent. After 46 years of faithfully reporting from the edge of the solar system and beyond, the spacecraft stopped sending coherent data, transmitting only garbled signals across 15 billion miles. This wasn't just a technical glitch, it was a crisis for humanity's farthest-reaching explorer, a spacecraft running on 1970s technology that had already outlived every expectation. NASA engineers traced the issue to a corrupted memory chip, likely damaged by one of the very cosmic rays Voyager was studying. The irony was stark. The spacecraft was wounded by the same high-energy particles it was sent to investigate. The fix was nothing short of a technological miracle. Engineers had to rewrite and reroute code from 1970s hardware into backup memory areas, all while communicating across a distance so vast that radio signals take over 22 hours for a round trip. This was digital brain surgery performed on a patient older than most of the engineers working on it, using commands written when disco was still king. By April 2024, Voyager 1 showed signs of life. Basic engineering telemetry, the spacecraft's vital signs began trickling back. By May, the magnetometer and plasma wave instruments were back online. And by June, all 4 active science instruments were functioning again. This wasn't just a repair, it was a resurrection. NASA didn't just save Voyager, they extended humanity's only direct link to interstellar space, buying us precious years of data from a realm we may not revisit for decades. Each measurement Voyager sends back is a gift, a piece of the interstellar puzzle that's reshaping our understanding of the galaxy. Voyager 1's mission goes far beyond collecting data. It's helping humanity chart the uncharted. With every faint signal it sends, the spacecraft is laying the foundation for a navigational map of interstellar space, a kind of galactic GPS that could guide future missions. Scientists are using Voyager's measurements, cosmic ray gradients, particle density readings, and magnetic field orientations as anchor points to build three-dimensional models of the Milky Way's invisible structures. This isn't theoretical modeling, it's real-world cartography of the cosmos. The radiation patterns and magnetic twists Voyager detects are revealing the galaxy's hidden skeleton, from low-density voids to dense plasma clouds. These structures could one day serve as safe lanes for spacecraft or shields for astronauts venturing beyond our solar system. The radiation in interstellar space is far more intense than anything in Earth's orbit, and understanding where the danger zones and natural shelters lie could mean the difference between life and death for future explorers. Some scientists even believe Voyager's data could shed light on star formation itself. The magnetic field orientations it measures may channel cosmic material into denser regions, potentially sparking the birth of new stars. Voyager isn't just surviving, it's quietly drawing the first real blueprint of interstellar space, a map that could shape humanity's future in the cosmos. Forget the idea of space as a static, empty void. Voyager 1 has revealed that the interstellar medium is a dynamic environment, complete with its own weather patterns, currents, and boundaries. Since crossing the heliopause, Voyager has encountered at least 2 distinct interstellar cloudlets, regions where the density of plasma, dust, and gas shifts dramatically, sometimes doubling or tripling in density. These aren't visible clouds like those on Earth. They're invisible to our telescopes, detectable only by Voyager's sensitive instruments. The spacecraft has also found evidence of structured plasma ripples like atmospheric fronts in space, with clear boundaries and distinct characteristics. These findings suggest a level of organization in the interstellar medium that astronomers never anticipated. NASA scientists now believe our sun is moving through the local interstellar cloud, a feature within the larger local bubble, a massive cavity carved out by ancient supernovae. Voyager's data is helping define the edges of this cloud, revealing a cosmic landscape that's far more textured and intricate than we ever imagined. These discoveries have implications that reach all the way back to Earth. The density shifts Voyager detects could influence our planet's exposure to cosmic rays over millennia, subtly affecting everything from cloud formation to genetic mutation rates. The edge of our solar system isn't a clean boundary, it's a chaotic swirl of plasma, radiation, and magnetism, a gauntlet of invisible forces that Voyager is navigating in real time. Voyager 1's scientific mission may wind down in the coming years as its power supply, fueled by a decaying radioisotope, finally runs dry, but its journey is far from over. This small spacecraft will continue coasting through the cosmos, a silent ambassador carrying humanity's essence into the infinite void. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of Gliese 445, a red dwarf star, a cosmic near-miss that underscores the vastness of its journey. What makes Voyager truly unique is its golden record, a time capsule etched with the sounds, music, greetings in 55 languages, and 116 images of Earth. Designed to last over 1 billion years in the harsh environment of space, this record is humanity's most enduring monument. Long after our planet's continents have shifted beyond recognition, long after our civilization has transformed or vanished, the golden record will remain, a pristine snapshot of who we were in the 1970s. Voyager is more than a probe. It's a cosmic emissary, carrying our story to the stars. No other human-made object will leave the heliosphere for decades, perhaps centuries. Voyager 1 is our longest-lasting trace in the universe, a testament to our curiosity, ingenuity, and desire to connect with whatever or whoever might be out there. So what has Voyager 1 truly found beyond the heliopause? No aliens, no wormholes, no portals to other dimensions. Just something far more real and infinitely more fascinating. The interstellar medium isn't the featureless void we once imagined. It's a dynamic, structured environment with its own weather patterns, magnetic topography, and radiation zones. The transition from our solar bubble to interstellar space is messy, complex, and brimming with surprises. Magnetic fields twist in unexpected ways, cosmic rays bombard with unrelenting intensity, and plasma waves hum with the galaxy's rhythm. Perhaps the most profound discovery is this: our solar system is a sheltered oasis, a cosmic haven shielded by the sun's heliosphere from the harsh radiation that fills the galaxy. Voyager has shown us that we live in a protective bubble, a calm harbor in a stormy cosmic sea. But the data it's sending back isn't just about survival, it's about understanding our place in the universe. Each measurement refines our map of the galaxy, revealing a landscape of invisible forces and ancient events that shaped our stellar neighborhood. What will Voyager find next? Will it encounter another interstellar cloudlet, a new magnetic turbulence zone, or perhaps the faint echo of a long-forgotten supernova? The possibilities are as vast as the cosmos itself. As Voyager continues its lonely voyage, it's not just collecting data, it's rewriting our story, challenging our assumptions, and inviting us to dream of what lies beyond. This is real science, unfolding in real time, and it's a story that's only just beginning. For those who love the nuts and bolts, here's the backstory that makes Voyager 1's journey even more remarkable. Launched on September 5th, 1977, Voyager 1 was initially tasked with a grand tour of the outer planets, capturing stunning images of Jupiter and Saturn before slingshotting into the unknown. In 2012, it crossed the heliopause at roughly 11 billion miles from Earth, becoming the first human-made object to enter interstellar space. The spacecraft carries a suite of instruments, including a magnetometer, plasma wave system, and cosmic ray detector, tools designed for planetary exploration but now repurposed for the interstellar frontier. These instruments, powered by a radioisotope thermoelectric generator, have proven astonishingly resilient, though their power is fading. In September 2024, NASA engineers performed a critical thruster swap to maintain Voyager's Earth-pointing attitude, bypassing clogged fuel lines that threatened to end the mission. In early 2025, facing dwindling power, NASA made the tough call call to shut down the cosmic ray detector to extend the mission's life, leaving 3 science instruments still operational. Every signal Voyager sends back is a feat of engineering. At just 23 watts, equivalent to a dim light bulb, these transmissions take over 22 hours to reach Earth across 15 billion miles. Each day Voyager operates is a bonus, a gift of knowledge from the only human-made object sampling interstellar space firsthand. As its power fades, Voyager's mission is a race against time, but its legacy will endure for millennia. Voyager 1's journey is not just a scientific endeavor, it's a testament to the human spirit's unyielding desire to explore the unknown. Launched in an era when computers filled entire rooms and the internet was a distant dream, Voyager represents a pinnacle of human ingenuity and ambition. The spacecraft was built with technology that by today's standards seems almost primitive, yet it continues to function, sending back data from a distance that staggers the imagination. This resilience speaks to the vision of the engineers, scientists, and dreamers who dared to send a piece of humanity into the cosmos, not knowing if it would ever reach its destination. The Golden Record, in particular, captures the essence of this ambition. It's more than a collection of sounds and images. It's a love letter to the universe, a declaration of our existence, our creativity, and our hope. The record includes everything from Beethoven's symphonies to whale songs, from greetings in ancient Akkadian to modern English, from images of a mother nursing her child to diagrams of DNA. It's a portrait of humanity at a specific moment in time, a snapshot of who we were when we first dared to reach beyond our solar system. Voyager 1 carries this message, not just for potential extraterrestrial finders, but for us, reminding us of our capacity to dream big and to create something that outlasts us all. To fully appreciate Voyager 1's discoveries, we must place them in the broader context of our galaxy. The Milky Way is a barred spiral galaxy, home to hundreds of billions of stars and countless mysteries. Voyager 1 is exploring a tiny sliver of this vast cosmic tapestry, yet its findings are illuminating processes that operate on galactic scales. The magnetic turbulence zones, plasma density spikes, and cosmic ray corridors it detects are not isolated phenomena. They're part of the intricate machinery that governs the structure and evolution of the Milky Way. The local interstellar cloud through which Voyager is currently traveling is itself a small feature within the local bubble, a cavity roughly 1,000 light-years across, carved out by supernovae millions of years ago. This bubble is not static, it's shaped by the dynamic interplay of stellar winds, magnetic fields, and cosmic explosions. Voyager's data suggests that the boundaries of these structures are not smooth, but jagged, marked by abrupt transitions in density and radiation. These findings are helping astronomers refine their models of how galaxies form and evolve, revealing a universe where even the spaces between stars are alive with activity and history. Voyager 1's mission is a beacon for the future of interstellar exploration. While its power will eventually fade, likely within the next few years, its data is laying the groundwork for missions that may not launch for decades. The navigational map Voyager is helping to create could guide future spacecraft through the radiation-filled voids of interstellar space, identifying safe paths and danger zones. This is critical for any mission aiming to send humans or advanced probes beyond the heliosphere, where the environment is far harsher than anything we've encountered closer to home. Moreover, Voyager's success has inspired a new generation of scientists and engineers to push the boundaries of what's possible. Concepts like Breakthrough Starshot, which aims to send tiny probes to nearby stars, owe a debt to Voyager's pioneering journey. The data Voyager has collected on cosmic rays, magnetic fields, and plasma dynamics will inform the design of these future missions, ensuring they can withstand the rigors of interstellar space. Voyager 1 is not just a relic of the past, it's a bridge to the future, a stepping stone toward humanity's next great leap into the cosmos. Voyager 1's journey forces us to confront profound questions about our place in the universe. As it drifts through the interstellar medium, it reveals a galaxy that is both beautiful and intimidating, a place of immense complexity and unrelenting forces. The discovery that our solar system is a sheltered oasis, protected from the galaxy's radiation storms, underscores how fragile and precious our home is. It's a humbling reminder that Earth is a tiny speck wreck in a vast cosmic ocean, yet one capable of producing a species that can send a probe to the stars. At the same time, Voyager's golden record invites us to reflect on what it means to be human. The record's contents, chosen to represent the diversity of our cultures, languages, and experiences, are a declaration of our existence, a shout into the void that says, we were here. Whether or not another intelligence ever finds the record, its creation was an act of hope, a belief that our story is worth sharing. Voyager 1 challenges us to think about our legacy, not just as individuals or nations, but as a species and what we want to leave behind in the infinite expanse of the universe. Voyager 1's success is not just a triumph of technology, but of human collaboration. The mission was born from the collective efforts of thousands of scientists, engineers, and technicians from around the world, working together to achieve something greater than any one nation or individual could accomplish alone. The Golden Record, for instance, was a global endeavor with contributions from cultures and languages spanning the planet. The decision to include greetings in 55 languages from Sumerian to Wu was a deliberate effort to reflect humanity's diversity, a recognition that our journey into the cosmos is a shared one. Today, the data Voyager sends back is analyzed by researchers across the globe, from NASA's Jet Propulsion Laboratory to universities in Europe, Asia, and beyond. This international collaboration continues to yield insights that transcend borders, reminding us that the quest for knowledge is a universal human endeavor. Voyager 1's story is a testament to what we can achieve when we work together, pooling our expertise and passion to explore the unknown and expand the boundaries of what we believe is possible. Voyager 1's detection of low-frequency plasma oscillations is one of its most haunting discoveries, a reminder that the universe is not a silent void, but a place alive with subtle vibrations. These oscillations, detected by the spacecraft's plasma wave instrument, are like the background hum of the galaxy, a cosmic symphony that resonates through the interstellar medium. Unlike the random noise scientists might have expected, these waves exhibit patterns, suggesting a level of coherence that hints at underlying structures within the galaxy. This isn't just static, it's the pulse of the cosmos, a rhythm shaped by ancient events like supernovae, stellar winds, and magnetic interactions that continue to echo across millions of years. These plasma waves offer a window into the dynamic processes that govern interstellar space. They could be the remnants of shock fronts from long ago stellar explosions, or they might indicate interactions between the local interstellar cloud and the surrounding medium. Scientists are now analyzing these oscillations to better understand how energy propagates through the galaxy, potentially revealing how cosmic rays are accelerated or how magnetic fields channel matter. Voyager 1 is not just a probe, it's a cosmic microphone, capturing the faint whispers of a universe in constant motion, and each note it records helps us decode the intricate dance of forces that shape our galactic home. As Voyager 1 ventures deeper into interstellar space, it faces an environment far more hostile than anything within our solar system. The intense cosmic rays, unpredictable magnetic turbulence, and shifting plasma densities create a gauntlet of invisible forces that test the spacecraft's resilience. Unlike the relatively calm environment inside the heliosphere, where the sun's magnetic field offers some protection, interstellar space is a raw, unfiltered frontier. Voyager's ability to withstand this cosmic storm is a testament to its robust design, but it also highlights the challenges future missions will face as humanity pushes toward the stars. This hostile environment has profound implications for future interstellar exploration. The radiation levels Voyager detects could pose significant risks to both human explorers and sensitive electronics, requiring advanced shielding technologies that don't yet exist. The magnetic turbulence zones and plasma density shifts could affect spacecraft navigation, demanding new propulsion and stabilization systems. Voyager 1's journey is not just a scientific expedition, it's a reconnaissance mission, providing critical data that will shape the design of future interstellar probes. By braving this gauntlet, Voyager is paving the way for humanity's next steps into the cosmos, teaching us how to survive in a universe that is as unforgiving as it is awe-inspiring. Voyager 1's story isn't just about science, it's about humanity's relentless drive to explore, to question, to understand. It's about a machine built with 1970s technology that's still teaching us about the universe nearly half a century later. It's about engineers who performed a miracle 15 billion miles away, about scientists piecing together a map of the galaxy, and about a golden record carrying our voice to the stars. This is the real stuff, no hype, no fluff, just the awe-inspiring truth of of what lies beyond. What do you think Voyager will find next? Could it stumble upon another cosmic boundary, a new kind of interstellar weather, or evidence of galactic events we can't yet imagine? The universe is full of surprises, and Voyager is our guide. Stay curious, keep exploring, and let's see where this cosmic journey takes us next.